your host for this morning's Tech Talk. Before we begin, I'd like to acknowledge our industry partners, Conquest, Kelledy Jones Lawyers, Plumbing and Pipeline Solutions, Roadside Services and Solutions, SEM Group, Solo Resource Recovery and Tonkin. I'd also like to extend my gratitude and thanks to Lyn Terrett and Scott McKennie from RapidMap for their support of this event, where we are talking about asset feature extraction, the new frontier. Our first speaker is Lyn Terrett, Spatial Technologies Director from RapidMap. Lyn is dedicated to the digital transformation of distributed workforces by mobilising maps, data and spatial positioning technologies to increase productivity and profitability. Of note, Lyn was the Director of Spatial Technologies at the National Geographic Society post 9/11 for Homeland Security, Critical Infrastructure and Counter-Terrorism initiatives. Lyn will be covering the first 9 slides and then we'll move over to Scott McKennie. Scott is a business analyst and solutions architect and head of R&D and IT at RapidMap. Scott brings a wealth of knowledge to the team at RapidMap in GIS solution architecture, mobile application software development, and spatial data integration. Scott's particularly interested in how to rapidly extract features from images for digital engineering. Over to you, Lyn.
Hey. Thank you very much, Brendon and Julie, for inviting us to speak today. I'm just going to share my screen and get moving. So there we go. Hang on. Here we are today to talk about asset feature extraction. I mean, one of the things that we've discovered with respect to remote workforces these days, you know, due to the COVID pandemic is that there's so much work to do, and yet so many of us have been locked down and unable to get to the field. You know, we've been unable to cross the borders. We've been unable to really conduct work the way that we would like to normally conduct work. But there's been some, you know, tremendous opportunities in that as well, in that we've really had to look carefully at how to maximize our time, you know, how to work more collaboratively with each other. And if anything, it's really given us an excellent opportunity to transform the way that we do work through whether we want to call it digital engineering or digital twins or along those lines, but essentially how to do what we promised to do, which is rapidly map and manage data for public works. Now, we've been in business nearly 30 years now, and we focused on public works. I mean, we absolutely adore the provision of field services, you know, to maximise the value of assets, the lifetime of assets, to really, I guess, if anything, we're spatial auditors. You know, we like to help our customers from the early days of amalgamations when we went from 280 councils in Victoria to 78, you know, and in that process, people realised they didn't know what they owned. They didn't know where it was. They didn't know what condition it was in. It was very difficult to conduct audits, to value, to depreciate, and actually to then justify, you know, maintenance around that kind of framework too. So we live for rapidly capturing information. But today, you know, with Scott's help, we're going to share with you some practical insights about, you know, asset feature extraction as sort of like a new frontier. It's not easy, but it's also not hard if you really set your mind to it. So in terms of the last image I was showing is that there's practical and easy ways to actually not only capture 360-degree imagery, but to understand that as we go along the roadway, you know, we can share a unique virtual experience with others, you know. So in that space, we can actually look at information as a way of capturing data once, but using it for many, many purposes, you know. So by having that seamed 3D, you know, view we can actually find better ways to capture information, share information, create GIS data, and create information that can go into asset management systems, you know, where every pixel in the image is its own three-dimensional, accurate, precise location. So, you know, there's a lot of challenges out there for road management, but we certainly have room for improvement. So one of the key areas, of course, is, you know, dealing with things, working safely along the corridor, working remotely together, working collaboratively, you know, monitoring pavement condition, dilapidation, you know, verification and validation of, you know, accurate asset registers. I mean, things are changing all the time, you know, but in this COVID world, what will be normal? I'd really like it if you were able to share in the chat, you know, some of the challenges that you're having in public works at the moment. Now, you're not as locked up as us. I think we're approaching around about 238 days. But some of the areas that we have been surveying and getting feedback from our customers are concerns around, you know, roads in terms of fire and flood, you know, and disaster management, storm damage, etc. So one of the great advantages is, of course, you know, risk management, disaster management, the asset inventories that we can create for asset, you know, a faster way for asset data capture in terms of these sort of linear objects that we're servicing, pavement management, contractor monitoring, you know, line marking, signage, traffic controls, you know, generating your road management plans with some confidence. You know, if we capture this once, great data in 360 degrees, and we share it with each other, you know, we're actually also putting a foundation behind intelligent transport systems and a better way to share that information, you know, so that you've got driver-assisted systems made available, you know, in the new Tesla cars, etc. So if you look at the fire image here, and we've been working with fire and emergency services organisations since the early 90s. We wrote the first fire mapping software in the world using GPS, and in those days, people couldn't even spell GPS. But you look at the barriers there, you look at the effect that fire can have on roads, on fences, on barriers, on bollards, on signage, on vegetation, and the risks. But in addition, you know, we have issues in terms of floods and other types of storm damage that can occur. So if you're actually able to travel along the roadways, you know, and capture that 360 image and intelligence, then when this is just 2021, the images I've shared with you in the previous screen for fire and this screen for flood, this is all this year and late last year. So how do you reach out and access some of that disaster funding? You know, the only way to do that is through actually evidence-based data capture, something geospatial along the roadways that can help you to justify. I mean, you look at the amount of flooding here. I mean, along the roadways, along the streets, affecting every property, you know, it can't help but cause a lot of damage along the roadways. How do you manage that in the post-disaster scenario? So in terms of providing you a little bit of a case study,
yeah, awesome.
Can you hear okay? So this is a particular project that we did for Vic Roads, where we were travelling along the different roadways. If you look down to the centre image, you can see, you know, signage on your left, you can see a barrier on your left, you can see an approaching truck, you can see how narrow that road is, you can see the road lines. So the wonderful thing with the systems that we've been assembling is that in capturing with high resolution cameras, learning how to trigger it really effectively, using great accuracy in terms of not just GPS, GNSS, but also inertial systems, you know, we're able to travel along the road and we're able to actually map points and lines, polylines and polygons to create really good information about, the signs and the assets along the roadway. But it doesn't just stop with assets. I mean, think about the vegetation, think about, storm damage, the trees. Earlier this year up in the Dandenongs, we had an enormous number of trees that fell and took out power lines and closed roads and communities, and for actually days and days, and in some cases weeks, people didn't have power. This is an advantage of actually having captured these roads. If you look on the image to the left, you can see that we're able to swivel the image in situ as we travel along the roadway. So capture once, use it many times on the desktop, and we can actually look to the side and look at vegetation. We can actually capture, say maybe native garden beds, look at barriers and bollards and information that's on the side. Maybe it's for weed management. Perhaps we're looking at precarious trees or vegetation management under power lines. But essentially, we've really, with Scott's help, one of the great things about COVID is that we can really focus in on, R&D, how to improve efficiency, how to do things in a collaborative space online with a remote team. And there's nothing better. But essentially, we've come down to 4 key processes. The first is to go to the field and to map and manage and capture that. Now, that requires a lot of hardware, a lot of technology, a lot of insight in how you set up, measure and focus your equipment to do the job at hand. So the first part of that is actually setting up your equipment and going to the field and capturing that. And you have to think about, weather conditions. You have to think about, sunshine and daylight hours. You have to think about shadow. So when you are going to the road, and going to the field, you actually have to look at, well, the equipment is suitable for this particular type of daytime environment. And you plan your routes and you go out and collect. Now, the second step is to actually post-process all that data to make it useful and usable. So the interesting thing is that while it might look like video, it's actually a series of still triggered images. And when you process that with the IMU data, you're able to get it to extraordinarily highly precise seamed images, so that you can take the measurements that you need and get within the parameters that your clients need. And that's what we focus on: speed, accuracy, precision. So post-processing it with the right data is also really key, and having the right computing systems to do that. The third step is actually sitting down and doing that feature extraction. So, training up your team, having them being able to measure, map, and create data with a very high degree of accurate information or intelligence associated with that. Now, this is where it now becomes a bit of fun, because we can look at images and start to think about artificial intelligence, machine learning, deep learning, and that really comes down to classification. And you need a lot of data points to classify and perhaps start to feature extract. So we're taking you on this journey. So the fourth level there is the opportunity to actually have that data hosted in a web server, such as an AWS, and that's the type of thing that we would do. We provide a managed service to provide our clients with a 360-degree street view that's personalised to their specific needs. But also there's the opportunity to be able to have them classify and to do feature extraction of things that are going to reoccur in their environment. Now, with that, what I'm going to do is I'm going to hand over to Scott so he can take us on a little bit more of a journey. But what would be fun is if you can put into the chat, what you would use 360-degree camera capture along roadway for. So take a few moments and enter that while Scott's getting ready. Scott, if you'd like to let me know, I'll change slides whenever you're ready.
Oh, okay. Yeah, no, I'll start with this one. Hi, everybody. I'm Scott McKennie. I work in a lot of different R&D projects and solution architecture projects for Lyn at RapidMap. I'll just go through some of the lessons learned from getting engaged in this type of process of doing the 360 data capture, and also just basic image data collection. As we've had various types of projects around that, but in this particular one, just consider that from a physical hardware solution, there's things that you're going to have to install and set up. There's you're going to have a way of integrating hardware with the vehicle. Some people use CAN bus. There's other ways of doing that as well, which is using external distance encoders. You can plug into the speedometer directly. There's things like that you actually need to use to get accurate pulsing or accurate signals to be able to send over to the cameras and the computer to be able to start generating imagery. So there's a whole bunch of different things that mesh together there to enable you to be able to capture those images quite rapidly. So we try to capture everything at about, I think, every 5 meters, and so we set those things up. Other alternatives are very expensive systems such as our Planix, which is inertial based, paired with GNSS, as well as a gyroscope, and I guess you've got an accelerometer in there. And all of that is very intimately tied together to be able to help produce good pulsing or good events to be able to capture those images. And these events, the signals that we get from either the vehicle or the high precision GPS, they all get fed directly into the camera to get the camera to trigger at every one of those events, and then the computer scrapes those images down. And you'd hope that the programming language is fast enough while handling everything else in order to pull those images down quickly, as well as taking the coordinates from the GPS at the same time. So there's various things that you need to consider, which is obviously the installation, the camera, the programming language that you might be using. If there's already software pre-built, that might be better if it's got really good performance. Obviously, you want to have really good GNSS receivers. How do you make sure that the geospatial data is accurate? Well, there's a level of post-processing that has to come into play afterwards as well. There's so many different levels of that you might have to consider when engaging one of these projects. So Lyn, if we can move to the next slide.
Oops, trying to. There we go.
Yeah, so just on that collection front, as I said, installation, configuration, setup, some of the calculations that you have to do prior to, the types of cameras that you might be picking. Some of them can be quite expensive. Some of them don't have to be so expensive. Obviously the GNSS receiver, IMUs, or the distance encoder, the DMI, if you want to go down that route. The computing power, how well, what sort of power do you have access to in that vehicle, and how grunty does the computer have to be versus how lightweight? Do you need a UPS? What's your backup power if the car drops out? Are you going to lose all your data? And then yes, there's the weather considerations as well. Is it a rainy day? You probably don't want to go out. And every 15 minutes you might have to get out of the car and clean the cameras. So we'll just move on from there. So we've got just a small video of one of our trials around the office. Alrighty. After you've actually gone out and done the collection, you want to correct the data with some base station data if you've got some sort of relationship with I don't know. So maybe it's Trimble, maybe you want to set up a VRS. There's multiple ways that you can do this, but you want to try and get that geospatial data as accurate as possible, so that when you're starting to do your manual feature extraction within the application, you want that to be as accurate as possible as well, because the image is only as good as the geospatial location it's on, and then also the distance away from the camera is also going to be indicative of how accurate your actual position is. So some of the outputs that you can get from that is, you'll be able to draw imagery or, derive features from that imagery. You can create AR overlays. So say if you've got WFS or a WFS that you want to plug into that, almost street view type of environment, you can do that too. You can extract things manually. And you can also share the 360 street view with others if they want to derive different types of insights from the data collection that you've performed. Next screen. Alrighty. So yeah, the manual feature extraction component. So there's various ways of doing this. You can just draw immediately from the 360 view. You can create different types of, there's a layer manager in there. You're obviously going to want to do points, lines, polygons with Z values so that you can get the approximate height. You want to configure the forms and the form types. Usually you just want them to be as simple as possible so somebody can come back over them later. Some of you can also have autofill features in this. And in order to get to that next step for automated feature extraction, you're going to want to get a lot of examples. One of the other elements to this is that if you want to get super accurate points, lines, polygons, you can also apply a triangulation method, which is from different pictures. So we've got like 1, 2, 3 different pictures. You're drawing a singular asset. You can use a triangulation method, which we've got built into the software, to be able to draw the asset more accurately. So point, line, or polygon, you say it's a pit, you might want to drop 3 points using a particular mechanism, and then you can have that as part of your layer manager. It corrects the geospatial location, makes it a heck of a lot easier. Here's just an example of being able to, do the height of a sign. It's just a quick example of a quick draw up. You might want to open that up, fill out some details. All these forms are configurable to whatever it is that you want. You can put in height, but yeah, there's other methods of being able to autofill those forms as well. All right, Lyn, next slide. Okay, so the machine learning feature extraction. So once you've actually built up a good set of data, you're going to want to bring all this together. You need at least 1,000 examples to start building the various algorithms. We've got an API in the back end that allows people to interact with the 360 imagery and start processing it with machine learning algorithms. Alrighty, so just for those that aren't familiar with how computer vision works, I just thought I'd go through a very basic example. So this is how a computer might perceive an image. It's think of an Excel spreadsheet, and each cell contains 3 different values, and that would be red, green, blue, and sometimes you can have a grayscale in there as well, so it could be 4. But the idea is that you use all of these for a basic classification model. You use all of these numbers to build up a set of averages. So if it's if you're trying to identify a particular type of asset, or maybe it's an animal, could be anything, you build up averages of these types of images, and those averages can be a statistical weighting that gets used when trying to classify an image next. So you might have 20 different classifications, or let's just say cat, dog, rooster, and you put all of these in different folders. You process them through an algorithm, and that algorithm holds onto that statistical average for you. So it's just getting an idea that at the end of the day, this is just pattern recognition on the back of numbers, or averaging. And so it just makes it easier for people to understand if they're not familiar. So from the automated feature extraction end, how much data do you need? I would say 1,000 examples for each type of classification type. So before we even get to this level where we're doing our field collection, which we go out and about, and we start running our machine learning algorithm over the top of it, you need that 1,000 examples first. Then you have your the algorithm gets written around that data set, and then you can start doing change detection on it as well. So if you wanted to go down that route with this particular one. Yes, so in the chat, AWS AI tools can be used as well. If necessary, you can also, I believe they've got various services to allow you to get some people to help you with the object detection drawing. So when you're creating your set, if you want to focus on an object, so as opposed to a classification model where it's just a whole image, object detection, you want to draw a box around a particular object, and that'll help you identify certain things. They've got services where you can actually get people to help fill out that a set of data for you. So if you've got some examples, you handball it over to them, and they'll continue to create those examples for you. So yeah, this is just an example of the web view for collaboration. So part of the services that we provide is that once you've gone out and done your collection, if you need to share that with others in order to do the types of collaboration, you can actually have your own personalized street view. This can have WFS embedded. So I mean, I tried to get it working before this meeting with one of my colleagues, was just getting the WFS overlay. Couldn't get it done before the meeting, but you can have property boundaries set. You could, if it's super highly accurate, it looks a lot nicer than if it's maybe 10 meters out. So you want to make sure that whatever data that you're putting in here for WFS is highly accurate. You can also share the collected assets and infrastructure. So if you're doing trees or poles or anything like that, those particular assets can be shared through here, and people can inspect what that is. And if they need to do visual inspections of various types of assets, given the fact that we're all living in COVID times now, you'd want to allow people to be able to visually inspect without actually having to go out and about. So this is one angle, or one way in which we can engage that. So here is geotiffing export. So one of the great things about this product is that you're able to create your own roadmaps. So when you can end up creating polygons, and as the car's driving out, it'll pick up different various areas where you can create these geotiff tiles, pair them all together to create a map. So if somebody's working on line markings or needs to do defect detection, you can do that from even a bird's eye view as well by extracting it from the 360 view. So it's a really good tool for helping to manage line markings where required. And also, just doing basic defect detection. Okay, so so this is also doing some machine learning or some detection. So we can actually do, I think we mentioned this, change detection on various types of objects. The whole process, as said before, you want to grab the data, get some pre-processing on it. So maybe that's just correcting the geospatial. You might have a deep learning segmentation. There's various elements that you can blend into this process. Then you might have some element of computer vision post-processing. So you can actually split images up into different formats to be able to identify things a little bit better and use those as separate data formats. So then you'll have your machine learning classification model. Here, I just wanted to demonstrate on this particular part. This is from Tesla's AI Day. And I wanted to demonstrate just how far machine learning, and I mean, if you want to call it AI, how far computer vision and machine learning has come. It's gotten to the point where, not only can we do object detection, segmentation, obstruction detection, but you've got various different machine learning algorithms that can all tie in together. So the level of sophistication that, some organizations, of course, multi-billion-dollar organizations are working on at the moment for just the ability for driverless cars is just phenomenal. Even to the point where instead of relying on maps from like Google Maps, Bing Maps or anything like that, it's also using their computers, which are the cameras, which are practically stereo cameras, to start building up their own maps and their own understanding, so that they can sync that with every other car and continue to build better and better performance. So just, yeah, when it comes to this type of technology and where that technology is going, it's just becoming more and more sophisticated, especially in the deep learning space. So yeah, I'll probably end it here, but yeah, if you want to avoid these types of mistakes, maybe you should give us a call, and yeah, we'd be happy to talk to you about you know, what sorts of issues you might be going through and the types of solutions we've got on offer. Over to you, Lyn.
That's just too much fun. Yeah, so look, I hope you enjoyed that one too. Scott's got a wealth of knowledge, but look, it's a very interesting time that we're alive, you know, with respect to COVID. I mean, who would have thought this would happen in our lifetime? One of the areas that we're all very interested in, obviously, and concerned about is workplace safety and how people can work really safely in the roadway, in the road corridor, at safe speeds, you know, sort of like, so sending people out with their tablets that we do that for obviously stormwater, open spaces, parks, playgrounds, you know, you name it. And those are very efficient ways where there is no, say, road corridor. But if you are dealing with streets and, you know, footpaths and things like that, you really want to have that linear referencing. You really want to have that good network management, but you want to do it at speed, and you want to capture it once and use it many times. You know, as I've mentioned earlier about, you know, you know, what are some of your justifications? How do you build your business cases around why you want to get 360 camera capture, or what the value of a street view that's personalized to your council or your organization is worth to you, you know, in terms of collaboration. The capture once, use many. That pre-disaster, post-disaster view, you know, being able to look at things, have evidence, and be able to compare. But, you know, it's utilisation in terms of urban planning, you know, and development or monitoring, you know, periodically, a bit like NearMap, if you think about it. You know, NearMap flies every month, you know, then they provide, you know, fresh temporal views from an aerial perspective. You know, why not have a 360 camera capture of your own to give you your personalized street view? So, and have something that can help you to measure and then start to move into that machine learning, you know, artificial intelligent feature extraction space, you know. And now, how do you build those, you know, business cases? Well, then perhaps use the UN's sustainable development goals. You know, I've highlighted a few here that I think are quite relevant in terms of substantiating why you would undertake, you know, this kind of investment. The costings of this is actually coming down and down and down, and the more that we use it, the better we all get to be at it. As I mentioned, you know, our first thing was to actually fully understand and comprehend the sensors and the equipment that we needed to hook together, how we install that on the vehicle. If we're going to do something like that planimetric view to be able to give you a better understanding of your line marking or your pavement condition or dilapidation, you know, you really need to set up those cameras or choose the right cameras. You know, triggering those at interval or at distance is a really important key. So that first stage is all about the sensors and the equipment. The second stage is all about, you know, how we post-process or how we process that data to make it really meaningful, make it very useful for others. And then, of course, putting that into the right kind of software environment where we can do that feature extraction, whether it's manually or it's automated. The manual approach to it is a really good fundamental first step, because, you know, by measuring it and capturing intelligence, you know, in that context, then you have a better understanding about the repeatability of some of the tasks. And it's those repeatable tasks that you tend to want to translate into feature extraction or into machine learning, deep learning, and AI. Just going back to that though, is that the next step is, of course, you know, how do you host it and make that available? integration models. Scott is brilliant at integration and making those things available to other corporate systems. And then, of course, as I was saying, you can look at, AWS is the perfect vehicle for many of us to actually be able to put something up and share and also apply some good processing capability to make that feature extraction possible in this day and age. So you can explore the possibilities. You can stay in touch with us to stay informed. If you have any questions, if you want to address any particular projects, you've got some ideas in mind, then, believe me, there's a lot to learn. So feel free to contact us and talk to us. I think the private street view, from my perspective, is one of those really great benefits that people can enjoy and use to collaborate and get to faster decisions. One of the things that I've experienced in this COVID lockdown time is that, a 5-minute whiteboarding session with people who actually can really visually understand something is much better than, sort of 5 weeks of Zoom meetings and just talking around an issue. Actually, one of the other great things that Scott did in our lockdown period was create, the whole footpath quad bike capability as well, and such a lot to learn in building out these sorts of platforms and environments as you need them to be. So there's a link up here to the 360 mobile mapping information. If you want any further information at all, you're more than welcome to contact us at any time. I've put my mobile up there because obviously I'm working from home, and but there's the email addresses and things are there as well. If you have any questions, you're more than welcome to ask. So
Lyn, we do have some questions in the chat if you wanted to just. I think I've answered a few. Mm-hmm. Vince had one which was about Tech One customers. I don't know if I can answer that one. So you're probably more in that realm to be able to answer.
What's the question? Read it out to me.
Do you have any Tech One customers that are using the 360 camera for asset capture and condition assessment?
We have a lot of Tech One customers, and it's really about which sort of modules are you talking about using in terms of the integration? Are you looking at the asset management model? Are you looking at the financial modules? So Vince, have you got any information regarding that?
Just in terms of integration, the sky's really the limit. It's not. Well, these things aren't hard. Whatever data format that you might need something in, we can work something out.
Yeah, it's very easy to just pass, data from a database that's collected to Tech One or through to the Intramaps. If you're using their GIS module, you can feed it through that way and then into their system. But what we generally find with asset data capture is that there's data that is requested and required to go into different systems. So once again, capture once, use it many ways. Just because the data in the database, may be 100% looking like this, but it may actually be that 30% of it goes into this system and 30% of it goes into that system. So when we commence any project, we always look at data models in terms of, well, what's the end game? What reports do we need? Where does that data need to go? What data model is the data in that corporate system? So that we can then move from that end position. So starting with the end in mind, moving right back to the beginning, which is, well, this is what we need to capture, or this is how we need to process it, or this is what it needs to look at. It simplifies it if we really begin with the end in mind. I hope that's answered the question. But feel free to call if you want to discuss a little bit more about what you specifically might need in your Tech One system. Other questions? Any other questions there?
I've got one, Lyn. It might be more for Scott, but I'm assuming that all of these sensors and everything that you plug it into, the gyroscope, all of that sort of gear, all has a different programming language. How do you get everything to speak together?
Yeah, and that's that's an interesting question, because a lot of the different interfaces that you might have are all you know, you need some sort of centralized area where you're either you're grabbing the data from. So one of the methods that we have is we've got a product called an Aplanix. It's like a high precision GPS. It's got inbuilt the gyroscope, the accelerometer, and what is it? It's just a well-built GPS paired with an inertial system. So it can also provide us the events that we might be looking for. So say it's moving every 5 meters. It's pretty, really, really accurate in terms of that because of the accelerometer that's built into it. So it'll send us those pulses instead of us going to the car to grab those pulses from the car. What we do from there is that those pulses get fed into a thing called a trigger box. The trigger box is usually programmed in C. So it's like a microcontroller. If you've seen an Arduino or a Raspberry Pi, think of something like that. And so that gets used as almost like a central area for sending the pulses from one interface. So that could be the car speedometer, or that could be the Aplanix or some other form of distance encoder. And then that passes that message through to the cameras and the computer. So the computer realizes, okay, I've received an event. The pulses have been sent to a camera that recognizes, hey, every time I receive this pulse, I've got to take a picture. And so from there, the computer goes, okay, well, I've received an event. I've got to go grab a picture from the camera. And so the camera's already stored that image for you to grab. Then you've stored that image, stored the event and the geospatial location that you had at that particular point in time. And then you have to wrap all that together. And so the programming language that you use typically has to be quite fast. A lot of people use C++ because it's very fast. I've tried using Python on a particular quad bike project. If you're not careful, you can't go too fast because the programming language is just too slow if it's not programmed correctly. If you're using the C++ libraries or even the C libraries, it's perfectly fine. But the fact of the matter is, it's an what do you call it? An interpreted language. So as far as the C++ is more of a compiled and goes down to a much lower language after it's been compiled, so it runs a lot quicker. So that's probably the preferable language that you want to be working with. But all the other pieces of equipment, they have their own language, their own way of dealing with things. Usually that's in C. That all gets fed down into the computer, and then the computer runs, hopefully with C++, is able to grab things a lot quicker. I hope that answers your question.
Nerd alert there, Scotty. I know you're getting excited. So that's very good.
But I think there was a question from B. Austin. So what frequency of data capture is recommended? The frequency should always be at a point where you're overlapping, so you're creating chainage between images to images. So it depends on the angle of the camera. If let's say you've got two cameras, one front, one back, instead of a 360, you want to make sure that as you head, further forward, that the next image that you take captures the area that was underneath the vehicle that you were in at the time, and also anything else that you might be moving away from. So you want to create what's called a great form of chainage, and that's demonstrated in the GeoTIFF stuff that I was showing you before, which is having it at every 5 meters, if you've got the right angle for the camera, allows you to grab that chainage. So it's really just about making sure that each and every image connects to each other, so that you can build up so you can just have continuous data, and everything sort of flows together. So it's almost as if it is a video.
We might be able to answer that last question there on the cameras, GPS and GNSS.
That's a good question. Now, actually, with respect to hardware, our team our go-to is 4D Global. We included in one of the slides earlier, sort of Peter there's a range of different GNSS and IMUs and systems, you know, even for cameras and computers often, you know, we will take some guidance from there as well. But the IMUs of note we would tend to use would be a Planix, which is a Trimble based company, or so Planix gives us the best resolution. A Planix is what Nearmap and Aerometrics and others use as well, you know, for that control in the air, and they get their gear from 4D Global. So we tend to contact Peter and get that done. Yeah, but there's always a learning experience, and the keys with the key with respect to good computers is to have excellent GPUs as well. But power, you know, managing your power in a mobile vehicle, utilizing a UPS to stop any spikes, you know, to give that nice smooth power supply that's uninterrupted is really critical as well. There's so much to learn. So sort of like a small or mid-range council, it really depends, Brendon and team, you know, how long it's going to take to capture it. I would say, you know, roughly, depending on weather, and then, you know, because you want optimal weather, and depending on the time of year, because you really want good sunlight coming down so you don't have too much shadowing, I'd suggest, you know, anywhere from springtime to, you know, sort of September to March is probably some of the best times to capture. But it would probably take a few weeks, a month or so. Then it takes probably an equivalent or twice that to sort of like process, depending on what sort of information is to be extracted from there. And yes, we do put up fully hosted managed systems with all the applications. So, you know, we can help people with the equipment, we can help people with the service, we can help people with the output, we can help people with putting that into an environment that they can leverage, because, you know, a lot of them find that if they were to try and go to their own IT people and say, hey, we need this platform, we need this environment, they'll go, hey, you know, I'm working on helping all these people to work remotely, you know, I've got to deal with cybersecurity, I've got to deal with, you know, updates and upgrades to this corporate system. No, you'll have to go on the back burner. So it's easier to come to someone like us, you know, in RapidMap and our team, to sort of like put it up, host it, manage it, make it available to you, and then you can just leverage it to your heart's content. Okay.
Thanks, Lyn. That's brought us to the end of today. I wanted to thank Lyn and Scott from RapidMap for their presentations. Extremely interesting. Big thanks to our audience for their time. Please join us for our next session on the 13th of October, where we talk climate change and climate resilient asset management. And if you aren't already a member of IPWEA SA, please consider joining this great industry association. Have a great day, everyone.